So, good morning, everyone. Good morning, sir. I am Earth Alabata Balneg, first reporter of the Chapter 11 wastewater treatment as our assigned topic for this reporting. So, on this, at the end of this chapter, um, we are expected to explain the importance of wastewater treatment, distinguish wastewater characteristics, know wastewater treatment standards, explain the differences of domestic wastewater and industrial wastewater, um, discuss the three major categories of municipal wastewater treatment, be able to recognize several devices and structures used in unit operations of pretreatment, explain how primary, secondary, and tertiary wastewater treatment contributes to the whole system, discuss the processes of wastewater treatment, the importance of land treatment for sustainability, and describe the disposal of a residue after the wastewater treatment. So here's our topic outline. So the introduction, wastewater treatment perspective. So wastewater has historically been considered a nuisance to be discarded in the cheapest, least offensive manner possible. So what is the wastewater treatment? So treatment um, helps the wastewater to remove the contaminants present in the wastewater. So, as we remove the contaminants in the wastewater treatment, it can be disposed safely and reused safely for various purposes, and it can be also disposed for the return in the water cycle. So, it is important um, to have the wastewater treatment because as we all know, clean water is a basic commodity that should be treated such, and it should be conserved and reused because we living organisms, we humans, needs water to be able to live. So we are very lucky in the Philippines to have many um, water supply where we can get fresh water, rivers, dams, we have lakes, water reservoir, we have groundwater, wells, man-made wells. So we are very lucky to have that. Unlike other countries where they don't have um, clean water source, they don't have enough water supply, and given that they also have a big amount of number of population. So wastewater treatment is very essential for them to continue the cycle in the water and to continue support the population in their country. Okay, so so characteristics of domestic wastewater. So first, what is domestic wastewater? Domestic wastewater are the wastewater that comes from our households. This comes from our laundry, our bathrooms, our kitchens, anything that uses water in the vicinity of of our households. So that's why it's called domestic wastewater. So, physical characteristics. Fresh, aerobic domestic wastewater has been said to have the odor of kerosene or freshly torn earth, where aged septic sewage is considerably more offensive to the olfactory sense. Fresh, fresh sewage is typically gray in color. So fresh sewage is typically gray in color. These are the wastewater that comes from our laundry, our bathroom, our kitchens. It's gray in color because of the presence of our detergents and other um, solid materials that contributes to the gray color, while the septic sewage wastewater is black because of the presence of our solid waste, our feces, our and also our urine that we are disposing in the toilet. So these are the septic sewage wastewater. So its color is black because of the precipitation of iron sulfide. So we have the two types of solids in the wastewater, the seedable solids and the suspended solids. Seedable solids are the solids that can settle out in the liquid fraction in 30 minutes under quiescent conditions. Or the suspended solids, these are the solids that can't be settled out in a very long time. It will just remain in suspension. Okay? So, chemical characteristics. Wastewater has chemical characteristics in the domestic wastewater. Why? Because we humans consume food, and food contains chemicals. Uh, so the chemicals we consume, the chemicals we digest, are going to be disposed in the toilet in our urine, while in our through our solid waste. So, because the number of the chemical compounds found in wastewater is almost limitless, we normally restrict our consideration to a few general classes. So, these classes often are better known by the name of the test. So, one of these are the COD test, used to determine the oxygen equivalent in the organic matter, the total nitrogen, the to measure the total organic and ammonia nitrogen in the wastewater, and the biochemical oxygen demand, the measurement used to measure the amount of biodegradable organic matter present in the wastewater. So, as I've said, in our wastewater, there contains chemicals, especially in the septic sewage wastewater, because it's part of our diet. The chemicals that we intake will be part of the wastewater that we produce um, in the septic sewage. Okay, so and also chemical characteristic of the wastewater does not only limits to the what we consume. It also includes to the different chemicals we use, especially in the production process, the and also the in the laundry, the cleaning that we do in our households, the chemicals that we use, detergents, it all contains chemicals, and those chemicals will be um, will be um, will go with the will go along with the wastewater that we are producing. Okay, so wastewater treatment standards. So in public law, the Congress required municipalities and industries to provide secondary treatment before discharging wastewater. So it is important to have this not only pre-treatment and primary treatment, we also need secondary and tertiary treatment before the wastewater are discharged finally in the natural water bodies or the receiving bodies. Why? Because to remove all the grits, the chemicals, contaminants, the microorganisms is still present in the wastewater. Because if these materials or microorganisms, chemicals, um, will not be removed, it will affect the receiving body and the living organisms living on that receiving body or in the natural water bodies, and also it will affect back to the people. um, it will turn back to the people. Its effect will turn back to the people. Okay. So also directed that the EPA establish a permit system called the National Pollutant Discharge Elimination System. Under this MPDES program, all facilities that discharge pollutants from any point source into waters are required to obtain a MPDES permit. So, pretreatment of industrial waste. So industrial waste are the waste that comes from um, industrial places or industrial production. So examples of these are the companies or the structures that uh, manufactures products. The obviously they will use um, water as in their production process. So the wastewater that comes from these um, industrial places are called industrial waste. So these industrial wastewaters can pose serious hazards to municipal systems because the collection and treatment systems have not been designed to carry or treat them. So the waste can damage sewers and interfere with the operation of treatment plants. Why? Because industrial waste contains many hazard materials, chemicals, given that this wastewater comes from production process. So we don't know the chemicals, the other solids uh, that certain industrial mm, company is producing. So some hazard materials and chemicals will be included in the wastewater. So it really needs to have the pre-treatment of industrial waste before it is before it will be before it will undergo to a primary treatment plant, because if not pre-treated, it will damage the wastewater treatment plant because of the hazardous materials present in the wastewater that comes from the industrial waste. Okay, so they may pass through the wastewater treatment plant untreated, or they may concentrate in the sludge, rendering it a hazardous waste. So, the Clean Water Act gives the EPA the authority to establish and enforce pretreatment standards. So, we have the specific objectives of the pretreatment standards. So, this is to prevent the introduction of pollutants into the wastewater treatment plants. It will interfere with their operation. So these are the reason why there's a need of pretreatment, no? Because if the wastewater, as what I've said, if not pre-treated, especially if it comes from industrial waste, no, the it will interfere with their operation um, soon sa wastewater treatment plant sa primary na. So it needs to be pre-treated to prevent also of pollutants to pass through the treatment works or otherwise be incompatible with such works, and to improve the opportunities to recycle and reclaim municipal and industrial wastewaters and sludge. Okay. So lastly on my topic is the on-site disposal systems. So in less densely populated areas where lot sizes are large and houses are spaced widely apart, it is often more economical to treat human waste on site. So um, in rural areas where there are lesser population, it is economical to use on-site disposal systems. What are on-site disposal systems? These are the disposal systems near in the wastewater source where we can pre-treated it and final treatment and dispose it directly in the receiving body or in the groundwater. As seen on this diagram, we have the wastewater source, the collection and storage of the pre-treatment, the final treatment, undispersed. So the wastewater comes here, collection and storage, pre-treatment, and then here the final treatment dispersed. And once the wastewater is treated, it can be disposed in the directly in the groundwater. So in the groundwater, we have wells where we can get fresh water uh, clean fresh water from the ground. So that's all in my topic. Thank you for listening. So I will be giving the power. The next reporter will be my co-members. So thank you.
Good morning, sir. I'm Shakail Matthew Esesor. I'm second reporter, and our topic is all about Chapter 11, wastewater treatment. So, first is municipal wastewater treatment system. So, the municipal wastewater treatment system has three major categories. First is the primary treatment, which is assumed to include the pre-treatment process, which are the bar, grid chamber, and equalization basin. Its major goal is to remove the pollutants that will either settle or float from the wastewater, and it will typically remove about 60% of the suspended solids in raw sewage and 35% of the BOD5 or the biochemical oxygen demand. So the second is the secondary treatment, which its major goal is to remove the soluble biochemical oxygen demand that escapes the primary process and to provide added removal of suspended solids. It is assumed that it all includes the process of primary treatment, which are the bar, rock, grit, chamber, equalization, basin, and the primary setting tank. Secondary treatment is typically achieved by using biological process. So the third treatment is the tertiary treatment. It may involve chemical treatment and filtration of the wastewater, much like adding a typical water treatment plant to the end of the secondary plant. It may involve applying the secondary effluent to the land in carefully designed irrigation system where the pollutants are removed by a soil crop system. So, per unit operation of pre-treatment. So there are several device and structures that are placed upstream of the primary treatment operation to provide protection to the WTP equipment. So first is the barracks, which is typically the first device encountered by the wastewater entering the plant. Its primary purpose is to remove large objects that will damage or full pump valves and other mechanical equipment. So next is the grate chambers, which has three kinds. The rated grate chamber that is spiral rule with drives that grate into a hopper that is located under the air diffuser assembly. So grate are dense materials such as sand, broken glass, silt, and or pebbles. The second kind of chamber is the vortex. Vortex grate chamber. Here, the wastewater is brought in this chamber tangentially and at the center. There is a rotating turbine with adjustable pitch blades along with the cone-shaped floor that produces a spiraling donut shaped flow pattern. And the third type of chamber is the velocity controlled. It's known as a horizontal flow grate chamber. So, so the second device is the macroeaters that chop up wastewater solids like rugs, paper, plastics, and other materials by revolving cutting bars. So the third device is equalization or the flow equalization, which is not a treatment process per second but a technique that can be used in improving the effectiveness of secondary and tertiary treatment process here. The flow rate varies from hour to hour, reflecting a living habits of the area served. So next is here's the typical wastewater treatment plant flow diagram incorporating flow equalization. So other conditions that leads to the inclusion of equalization basin is in the process flow chain include combined sewers that lead to storm flow surges, likely pipes that allow significant volumes of storm water to enter the collection system, small plants with very high peaking ratios, industrial wastewater treatment plants that have high static flows or the potential for process functions that discharge large quantities of wastewater of very high strength wastewater. So we are now at the primary treatment. So primary treatment which the screening completed and gate removed the wastewater still contains light organic suspended solids, some of which can be removed from the sewage by gravity in a sedimentation tank. These tanks can be round or rectangular. The mass of settled solids is called raw storage. The storage is removed from the sedimentation tank by mechanical scrappers that pumps. Floating materials such as grease and oil rise to the surface of the sedimentation tank where they are collected by a surface skimming system and removed from a tank for further processing. So these are the diagram of primary setting tank. So that's it for my report. Thank you, sir, and God bless.
Hello guys, so I am Jimar Timran, the next reporter of the wastewater treatment. So under that, my report is the unit process of secondary treatment, disinfection, tertiary wastewater treatment. Overview, the basic ingredients needed for the conventional aerobic secondary biologic treatment are the availability of many microorganisms. All of microorganisms, the stabilization of the organic matter is accomplished biologically using a variety of microorganisms which convert the colloidal and dissolved carbonaceous to organic matter. Population dynamics, the microbial ecosystems. In the discussion of the behavior of agriculture that follows, the inherent assumption is that all requirements for growth are initially present. The Monod equation. For the large numbers and mixed culture of microorganisms found in the waste treatment system, it is convenient to measure biomass rather than numbers of organisms. Active sludge. The active sludge process is a biological wastewater treatment technique in which a mixture of wastewater and biological solids or the microorganisms is agitated and aerated. Complete mix activated sludge process. The desired formulas for the completely mixed activated sludge process are a mass balance application of the equation used to describe the kinetics of microbial growth. Sludge return. The purpose of the sludge return is to maintain a sufficient concentration of activated sludge in the reactor basin. Sludge production. The activated sludge process removes substrate, which exert an oxygen demand by converting the food into the new cell material and degrading this substrate by generating energy. Trickling filters. A trickling filter consists of a bed of coarse material, which the media, such as stones, slats, or plastic materials, over which wastewater is applied. Trickling filters have been a popular biologic treatment process. Oxygen demand. Oxygen demand used in those reactions required degrade the substrate to produce the energy required for cell synthesis and for respiration. Process design consideration. The STR selected for design is a function of the degree of treatment required. A higher STR results in higher quantity of solid being carried in the system and creates a higher degree of treatment. Secondary clarifier design consideration. Although the secondary settling tank is an important of both the trickling filter and the activated sludge process, environmental engineers have focused particular attention on the secondary clarifier. Oxidation pans. Treatment pans have been used to treat wastewater for many years, particularly as wastewater treatment system for small communities. Benefeld and Randall, 1980. Many terms have been used to describe the different types of system employed in wastewater treatment. Aerobic pans. The aerobic pan is a shallow pan in which light penetrates to the bottom, thereby maintaining active aerogel photosynthesis throughout the entire system. Anaerobic pans. The magnitude of the organic loading and the availability of dissolved oxygen, whether the biological activity in a treatment pan will occur under aerobic or anaerobic condition. A pan may be maintained in aerobic condition by applying a BOD file. So, by the way, there are five types of oxidation pans, which is aerobic pans, anaerobic pans, facultative pans, maturation or tertiary pans, and the lastly, aerated lagoons. Rotating biological conductors. The rotating biological conductors, or the RBC, process consists of a series of closely spaced discs mounted on a horizontal shaft and rotated while about one half of their surface area is immersed in wastewater. These discs are typically constructed of lightweight plastic. The speed of the rotation of the disc is adjustable. Integrated Fixed Film Activated Sludge, or the IFAS. This category includes any activated sludge system that incorporates a fixed film media in a suspended growth reactor. The purpose of the fixed film media is to increase the biomass in the reactor. Moving Bed Biofilm Reactor, or the MBBR. This process uses small plastic elements on the order of 7 to 22 mm effective diameter to support the growth of biofilm in the reactor. The suspended growth proportion of the hybrid is designed as a complete mixed reactor. Disinfection. The last treatment step in a secondary plant is addition of a disinfectant to the treated wastewater. The addition of chlorine gas or some other form of chlorine is a process most commonly used for wastewater disinfection in the United States. Tertiary wastewater treatment. The need for treatment of wastewater beyond that which can normally be accomplished in secondary treatment is based on the recognition of one or more of the following. Number 1.
Increasing population pressures result in increasing loads of organic matter and suspended solids to rivers, streams, and lakes. Number 2. The need to increase the removal of suspended solids to provide more efficient disinfection. And number 3. The need to remove nutrients to limit eutrophication of sensitive water bodies. Number 4. The need to remove constituents inhibit that preclude or inhibit water reclamation.
Filtration. The secondary treatment process such as the activated sludge process are highly efficient for removal of biodegradable and soluble organics. However, the typical effluent contains much higher BOD5 than would be expected from theory.
Granular filtration. By using filtration process similar to that used in the water treatment plants, it is possible to remove the residual suspended solids, including the unsettled microorganisms. Membrane filtration. One of the most commonly used in a tertiary treatment is microfiltration or the MF. Carbon absorption. Even after secondary treatment, coagulation, sedimentation, and filtration, soluble organic materials that are resistant to biological breakdown may persist in the effluent. The persistent materials are often referred to as refractory organic compounds. Refractory organic compounds can be detected in the effluent as soluble COD. Secondary effluent COD values are often 30 to 60 milligrams. Chemical phosphorus removal. Although polyphosphate or the molecularly dehydrated phosphate gradually hydrolyze in aqueous solution and to revert the orthoform or the PO3-4 from which they were derived. For example, terasodium pyrophosphate or the Na4P20 or the Na4P2O7 hydrolyzed in aqueous solution to form monohydrogen phosphate, which HPO2-4 typically found in wastewater. Na4P2O7 plus H2O 2Na2HPO4.
Biological phosphorus removal (BPR) or BioP or enhanced biologic BPR ABPR as it's sometimes called. The phosphorus in the wastewater is incorporated into cell mass in excess of levels needed for cell synthesis and maintenance. Microbiology. The original work on enhanced BioP identified Acinetobacter as the responsible genus, Enterobacter, Aeromonas, Mercadia, and Pseudomonas. Those are the different kinds of microbiology. Stoichiometry. Common heterotrophic bacteria in activated sludge have a phosphorus composition of 0.01 to 0.02 grams p over grams biomass. So this is the sample stoichiometry problem. So that we get the mole which is 0.240. Nitrogen control. Nitrogen in any soluble form is a nutrient and may be need to be removed from wastewater to help control algal growth in the form of phosphate. Nitrification denitrification. The natural nitrification process can be forced to occur in the activated sludge system by maintaining a cell detention time. So the lastly is the ammonia stripping. Nitrogen in the form of ammonia can be removed chemically from the water by raising the pH, convert the ammonium ion to the ammonia, which can be stripped from the water by passing large quantities of air through the water. So this is my report, and thank you.
Good day, guys. My name is Shed Rafael Cal, and our topic is all about Chapter 11 wastewater treatment. And I am the last reporter who will discuss this topic. And so let's go. Number 9, disinfection. The last treatment step in a secondary plant is the addition of a disinfectant to the treated wastewater. The addition of chlorine gas or some other form of chlorine is processed most commonly used for wastewater disinfection in the water. So, ang chlorine is very useful for cleaning wastewater and some water where there are so many pathogens. Chlorine can kill bacteria. That's why chlorine is very best for disinfecting water or any substance that has bacteria. Chlorine is injected into the wastewater by automated feeding systems. Wastewater then flows into a basin where it is held for about 15 minutes to allow the chlorine to react with the pathogens. Then, tertiary wastewater treatment. The need for treatment of wastewater beyond that which can normally be accomplished in secondary treatment is based on the recognition of one or more of the following. 1. Increasing population pressures result in increasing loads of organic matter and suspended solids to rivers, streams, and lakes. 2. The need to increase of the removal of suspended solids to provide more efficient disinfection. 3. The need to remove nutrients to limit eutrophication of sensitive water bodies. 4. The need to remove constituents that preclude or inhibit water reclamation. Filtration. Secondary treatment processes, such as the activated sludge process, are highly efficient for removal of biodegradable colloidal and soluble organics. However, the typical effluent contains a much higher BOD5 than would be expected from theory. So filtration is it is where in the secondary treatment processes that removes the decay or sludge from the water. And also, this is principally because of the secondary clarifiers are not perfectly efficient at selling out of the microorganisms from the biological treatment processes. And next is the granular filtration. By using a filtration process similar to that used in water treatment plants, it is possible to remove the residual suspended solids, including the unsettled microorganisms. Membrane filtration. The alternative membrane processes have been discussed in. Of the 5 processes, the one most commonly used in tertiary treatment is microfiltration. Next is carbon absorption. Even after secondary treatment, coagulation, sedimentation, and filtration, soluble organic materials that are resistant to biological breakdown may persist in the effluent. The persistent materials are often referred to as refractory organic compounds. Biological phosphorus removal. In biological phosphorus removal, the phosphorus in the wastewater is incorporated into cell mass in excess of levels needed for cell synthesis and maintenance. The phosphorus contained in biomass is removed from the processes of biological sludge. Microbiology. It is a study of microorganisms where it can be only seen in microscope, such as bacteria and viruses. Stoichiometry, it is a quantitative relation of how many substance like sludge has been used in order to become a chemical reaction. Nitrogen control. nitrogen is in any soluble form is a nutrient and may need to be removed from wastewater to help control algal growth in receiving body. In addition, nitrogen in the form of ammonia exerts on oxygen demand and can be toxic to fish. Removal of nitrogen can be accomplished either biological or chemically. Ammonia stripping, nitrogen in the form of ammonia, can be removed chemically from water by raising the pH to convert the ammonium ion into ammonia, which can then be stripped from the water by passing large quantities to air through the water. 11. Land treatment for sustainability. An alternative to the previously discussed AWT processes for producing an extremely high-quality effluent is offered by an approach called land treatment. Land treatment is the application of effluents, usually following secondary treatment, on the land by one of the several available conventional irrigation methods. Land treatment systems use one of the three basic approaches: 1. Slow-rate irrigation, 2. Overland flow, 3. Rapid infiltration. So, slow-rate irrigation, the predominant land application method in use today, involves the application of effluent to the land for treatment and for meeting the growth needs of plants. So, kanang mga ginabuhat karon sa mga farmers nga ilarang gina spray or abono unsa pa na diha watering nga para para matambalan ang mga nadaot nga soil and plants. The applied effluent is treated by physical, chemical, and biological means as it seeps into the soil. Second is the overland flow. Overland flow is a biological treatment process in which wastewater is applied over the upper reaches of slope terraces and allowed to flow across the vegetated surface to runoff collection ditches. Renovation is accomplished by physical, chemical, and biological means as the wastewater flows in thin sheets down the relatively impervious slope. So kani mura na siya og ang area sa plants or ang yuta mura na siya slanting position, slope para ang treatment niya is mura siya og baha ra bitaw. Mura siya og gikan sa taas nga source maigo na siya dito sa mga gasunod. So ang ikatulo, rapid infiltration. In infiltration, the percolation systems, effluent is applied to the soil at higher rates by spreading in basins or by sprinklers. Treatment occurs as the water passes through the soil matrix. System objectives can include 1. Groundwater recharge, 2. Natural treatment followed by pump withdrawal or the use of under drains for recovery, 3. Natural treatment where renovated water moves vertically and laterally in the soil and recharges a surface water course. So this is the image of the three basic approach of land treatment. So in here, the first one is the slow rate. As you can see here, it is all level and the application of chemicals and other substance is just in the root zone to the subsoil. And the second is the overland flow. As you can see here, the land is in slope form where there is a spray application and the water will just flow down to the grass. And third one is the rapid infiltration. It is where beyond the surface. Next, number 12, sludge treatment. In the process of purifying wastewater, another problem is created, the sludge. Sludge is like a mud or a dirt from the water. And the higher of the degree of wastewater treatment, the larger the residue of sludge that must be handled. The expectation to this rule are where land application or polishing lagoons are used. Sources and characteristics of various sludges. Grit. The sand, broken glass, nuts, bolts, and other dense material that is collected in the grit chamber is not true sludge in the sense that is not fluid. Second is the primary or raw sludge. Sludge from the bottom of the primary clarifies contains 3 to 8% solids, which is approximately 70% organic. This sludge rapidly becomes anaerobic and is highly odoriferous. Next is the second sludge. This sludge consists of microorganisms and inert materials that have been wasted from the secondary treatment processes. Next is the tertiary sludges. The characteristics of the sludges from the advanced wastewater treatment processes depend on the nature of the processes. For example, phosphorus removal results in chemical sludge that is difficult to handle and treat. Next is the solids computation. Because most WTP sludges are primarily water, the volume of the sludge is primarily a function of the water content. Thus, if we know the percent solids and specific gravity of the solids, we can estimate the volume of the sludge. Here you can see the formula on how to determine the mass of solids in a sludge. The volume of the total mass of solids may be expressed as V solids is equal to ms over SSP, where ms is mass solids in kilogram, SS is specific gravity of solids, P is density of water, which is equal to 1000 kilogram. Another formula, ms over SSP is equal to mf over SFP plus mv over SVP, where mf is mass of fixed solids in kilogram, mv is equal to mass of volatile solids in kilogram, sf is equal to specific gravity of fixed solids, sv is equal to specific gravity of volatile solids. The specific gravity of the solids may be expressed in terms of the specific gravities of the fixed and solid fractions. So here is the formula. SS is equal to ms times sf times sv over mf sv plus mv sf. Another formula, this one. These all formulas are helpful for us to determine the mass of the sludge. Sludge treatment processes. The basic processes for sludge treatment are 1. Sickening, 2. Stabilization, 3. Conditioning, 4. Dewatering, and 5. Reduction. So here in sickening, separating as much water as possible by gravity or flotation. Second is the stabilization, converting the organic solids to more refractory forms so that they can be handled or used as soil conditioners without causing a nuisance or health hazard through processes referred to as digestion. Conditioning, treating the sludge with chemicals or heat so that the water can be readily separated. Dewatering, separating water by subjecting the sludge to vacuum pressure or drying. Reduction, convening the solids to a stable form by wet oxidation or incineration. So this is the one example of the machine that can help remove the sludge. 13. Sludge disposal. Disposal in the air by burning is in reality not ultimate disposal, but only temporary storage until the residue falls to the ground. Although incineration is widely practiced as a sludge treatment advice, the ash and residues from air pollution control devices must be disposed of. Land spreading. The practice of applying WWTP residuals for the purposes of recovering nutrients, water, or reclaiming despoiled land such as a strip mine spoils is called land spreading. Landfilling sludge can be defined as the planned burial of wastewater solids, including processed sludge, screenings, grit, and ash at a designated site. So mostly in this case, na siya designated nga lugar para i-dispose ang mga sludge nga or hugaw nga para pod magamit sa yuta nga makakuha sila og nutrients and minerals ana nga waste. Dedicated Land Disposal or DLD is the application of heavy sludge loadings to some finite land area that has limited public access and has been set aside or dedicated for all time to the disposal of wastewater sludge. Utilization wastewater solids may sometimes be used beneficially in ways other than as a soil nutrient. Of the several methods worthy of note, composting and co-firing with municipal solid waste are two that have received increasing amounts of interest in the last few years. So that's all for our report, guys. Thank you and God bless you all.